Hello, welcome back to your channel, NCERT Tutorials. I am Sir here, Sir Durba, to guide you with circles. So we're still continuing with circles. Almost done, half part already done. Now maybe in just 3-4 videos, I guess we will be able to wind up the chapter on circles. Then maybe we can move on to some other new more interesting chapters. This is also interesting. So in the previous videos we have done up to question number 8. So this video will be on question number 9. So before we really proceed, I would kindly request you to please do watch the full video so that it will help me also. If when you watch the full videos, please do watch the full videos. And after watching the full videos, please do hit the like button if you have liked, share, and don't forget to subscribe. Subscribe mainly for the reason that you will be getting regular updates on any videos that comes up. And likes, that will always encourage me to work more for the student community. So I believe that you're all learning very well. I hope that you're all doing well, safe. And why I tell you to watch the full video is like all the hints, all the tips, all the tricks that we have to give about mathematics, we don't remember that. So when we solve problems, like every time as I'm solving, that something comes up. So okay, I tell you, okay, that is it, that you can use. Again, after 5 minutes when I solve, okay, something comes up again, that also, because in one list I cannot give you all the tips and tricks and do's and don'ts. So that's why I always say please watch the full video, so that it's going to help me and it's going to help you also. So today we're just going to do one video, one video of course, one question. So we are going to be solving this question. It's quite a slightly lengthy question, so we'll just do one on this. So that's why I want you to be along with this video. Bring your pen, paper, graph book. Okay, I wrote on the question. You can pause the video and then you can write down the question. For those who don't have the question, we can proceed now. So in the given figure, xy and x dash y dash are two parallel tangents. This is the diameter, and then another tangent AB that passes through, touching the circle at C. This is the point of contact. Now we have to prove angle AOB. This is my angle here. Angle AOB, we have to prove that this is going to be 90 degrees. Okay. I hope you've written down the question. I'm going to rub off class 10 mathematics exercise 10.2 question number 9. So at least we can start off with like what is given to. It's not of a very good color, isn't it? I tried with different colors, but two parallel tangents xy and x dash y dash. Another tangent AB, to prove. Let's first write down what we have to prove. After that we'll discuss 90 degree construction. What I'm going to do here is, definitely I'm going to need this, so I'm going to join this construction. What do is we join OC. Okay, we'll go to the proof. Now what am I going to do here? What am I going to do here with the proof here? It's very simple. What I'm going to do here is I have to prove that this is 90 degree. There can be many ways to prove, but today what approach that I'm going to use here is somehow if in the triangle AOB, if I can somehow find out that the sum of angle A and angle B, if these two angles is 90 degree combined, then automatically this third angle will be 90 degree. That's what I'm going to try to do here. How? That's also very simple again. How I'm going to do here is this. See, 2-3 concepts we're going to use. Okay, 2-3 concepts we're going to use. First concept is like when we have a parallel line and a transversal cuts through a parallel line, what happens is the sum of the angles on the same side of the transversal are supplementary. That means angle 1 and angle 2. So angle 1 plus 2 will be 180 degree. That's one concept that we are going to be using today. Okay, that's one of the concepts that we are going to be using today. Alright, second concept would be angle bisector. When we have an angle, we discussed in that first in lines and angles in class 9 video. There will be one video there where we have given you some introductions on lines and angles. You can just get through that once. We know that if a line bisects the angle into two halves, so that means if this full angle is angle A, then if it's cut into two parts, 1 and 2, so angle 1 and angle 2 will be equal and both of them will be half of angle A. So that's another concept which we are going to be using. The other concept that we will be using here would be about congruent triangles. Now we know that congruent triangles means all the angles and all the corresponding sides are also equal, and if that happens, what happens? The corresponding parts of the triangle become equal. That means, see, nothing is given here that these two angles are equal, so that's what I'm going to try to say. Because if I can do that, then one job is done. Okay, because if I can do that, then similarly these two angles will be also equal. That means this is half of B, half of A. Now we know that these two are parallel tangents. Sum of angle A and sum of full angle B 180. So half will be 90 degrees. That means half of angle A and half of angle B will be 90 degrees. That's what I was trying to do here. Half of angle A, half of angle B 90. So automatically in this triangle, this angle and this angle 90. So the third angle will be 90, 180 minus 90. That's going to be 90. Okay, let's begin. So it's very easy to recall. Take these two triangles first and try to prove that these two triangles are congruent. In triangle, okay, but before we do that, we'll just write tangent is perpendicular to radius through the point of contact. Okay, so this theorem is already written, so I guess you will have no problems. We can no need to write the same reason again and again, because in the beginning of the theorem we have already said once we write, then people will understand, okay, this guy knows about what he is doing. So in triangle OPA and triangle OAC, these two triangles OPA and OAC, what happens? Common side. OA is equal to OA, common side. Angle OPA is going to be equal to angle OCA. OPA, tangent, perpendicular to radius, point of contact. OCA, tangent, because AB is the tangent here. Because, see, already written here, so I think that should be enough, the way I feel, I mean. So both are 90 degree. Another thing, AP is equal to AC. Can you guess what was this property? Guess, AB. AP equal to AC. What was it? AP equal to AC. Tangents drawn from an external point are equal. Correct. That is, tangents from an external point are equal. So that's it. So triangle OPA becomes congruent to triangle OAC by right angle hypotenuse side congruency criteria, CRITERA criteria. So then that's exactly what I wanted. I can prove that. Shall I write angle 1, 2, or shall I just name the angle? Name the angle, that's better, I think. No? So angle OAP is equal to angle OAC. I'll write this A on top, okay? Then it's much more visible. No? Otherwise, written, I can just, please do write down the notes. Okay, equation 1. Not 1, let it be. Done? Okay, you can just pause the video, write down the notes. Done? Okay, I'm going to rub it off. So, angle OAP equal to angle OAC will be equal to half of angle PAC. That we can mark as equal, because PAC is a full angle, not this one, PAC. So, since both are equal, that means each individually will be half of BAC. Okay, that is done. Similarly, we are not going to prove again. No need. Similarly, but we will write this triangle and this triangle. Similarly, triangle OQB is going to be congruent to triangle OBC. So we're going to write straight. So angle OBQ, this and this we are trying to prove. OBQ is equal to angle OBC is equal to half of angle, or shall we just write this, CBCD. So angle OBQ and angle OBC each will be half of angle QBC. QBC. That one we can mark as equation 2. Okay, angle QBC. This angle, this angle. Color did not have any effect, unfortunately. One more try. This angle, this angle. Still no effect. Okay, I give up. Since xy and x dash y dash are parallel tangents, so coming back to that last point, and AB is the transversal. By the way, what was a transversal? A transversal actually was a straight line that cuts through two parallel lines. No? A straight line that cuts through two parallel lines. So for us, it's like PAC, something like C is here, doesn't matter, this angle, and QBC, this angle. So parallel lines. Oh, I rubbed it off anyway. So angle PAC plus angle QBC will be how much? 180 degrees. So I divide by 2 on both sides. So now half of QBC and half of PAC, I remember which angle that we wanted. The angle that we wanted was these two interior angles. So we're going to name them because we already proved half, no? So half of angle PAC will be equal to angle OAB, no? OAC. Okay, OAB, let's just write down, equal to angle OBC will be 90 degrees. Let's mark that as equation 1, 2, 3, equation 3. Okay, so now finally, so in triangle AOB, so finally coming back to the last point, this triangle 180 degrees. So angle AOB plus angle OAB plus angle OBC should be how much? 180 degrees. So angle AOB plus this we already proved 90 degrees, 180 using equation 3, 1, 2, 3. So angle AOB 180 minus 90. So angle AOB 90 degree, hence proved. Okay, so that's how this question will be done. Okay, so I was planning to solve one more question, but again I don't want to make the video too lengthy and for all of you, otherwise you will just get bored, isn't it? So we'll leave the next set of questions for the next video. So maybe the next video we'll be doing maybe another 2 to 3 questions. We will try to do it. So please, I hope you have watched the video full. If you have liked the video, please do hit the like button and please continue your studies. Stay safe, stay at home. See you in the next video then in your channel. Thank you.